This is Geometry, Semester 2, Midterm Review. We're going to be looking at the sides of our right triangle, and we're going to use the Pythagorean theorem because we have two sides of the right triangle, and we're looking for one side. So you've got to work with the hypotenuse, the leg, and the leg. So when you set up your formula, you always set it up where the legs are the perpendicular sides and the hypotenuse is always across from the 90. So you know exactly how you're going to set this up. You don't always set it equal to the variable. So we get 83.2 squared, 6,922, 4, 32 squared, 1,024, and z squared. Subtract the 1,024 and take the square root. Now notice how I'm taking the square root of the answer rather than typing in a rounded number. So we get 76.8 is the missing side. Again, we have two legs and a hypotenuse. We're looking for one side, so we know we're going to use Pythagorean theorem. We don't have any angle measurements, so trigonometry wouldn't help here. So we're looking for the hypotenuse this time. So that's why our variable is in the hypotenuse spot. We add our numbers together, take the square root of our answer, and that turns out to be a Pythagorean triple. Now here, we've got to decide if it makes a triangle, and once we decide if it makes a triangle, then we have to decide if it's acute, right, or obtuse triangle. Well, to decide if it makes a triangle, the two smaller sides have to add up to be greater than the larger side. So this adds up to 45. It's greater than 20. Yes, a triangle. Now we have to determine what type of triangle it is. So we're going to do our c squared and compare that with the a squared plus b squared. So we type in our numbers. We get our 417 squared is 289. I think we get 324. We add that to the 289. So 400 is less than 613. Since c squared is less than the sum of the other two sides squared, this is going to be an acute triangle. You got to be sure that you're doing it from the perspective of c squared, of the hypotenuse. It's not really hypotenuse because it's not a right triangle, but it's of the larger side. Here, we're going to compare our two smaller sides, and we hope that that's greater than 29. That's 2032, and of course that's greater than 29. So yes, a triangle. Now we got to figure out what type of triangle it is. So we're going to take the largest side and square it, compare that with the smaller sides and square them. So 29 squared, 841. 13 is 169. 19 is 361. Add the 169 to that, and we see that 841 is greater than 530. So therefore, it's an obtuse triangle. These are called special right triangles because they're 45, 45, 90, or they're 30, 60, 90. In a 45, 45, 90 triangle, you have the formula hypotenuse equals leg times root 2. So in this case, we don't know the hypotenuse. We know the leg is 7 times root 2. So to figure out the hypotenuse, you multiply the leg by root 2, so it's 7 root 2. We're looking for radical form, simplified radical form, so we do not want decimals. Here we got a few things to look at. We're 90 degrees on this side, so we're going to be 90 degrees on that side. 90 and 60 is going to leave this to be 30, so 90 and 60 leaves that to be 30. So we have a 30, 60, 90 triangle. We see that this is perpendicular, and if our two angles are the same, then the two sides are the same, so we know this is a perpendicular bisector. In other words, this has to be 16 and this has to be 16. Well, there's two formulas to work with a 30, 60, 90 triangle. The hypotenuse is going to equal the short leg times 2. We also know that the long leg is going to equal the short leg times root 3. So right now, what side have they given us? Or did we calculate? We calculated the 16. That's across from the 30. So that's the short side. So to figure out the hypotenuse, it's the short side times 2. So the hypotenuse has to be 32 also. And to figure out the long leg, which is your A, the long leg is the short leg times root 3. For number 7, again, this is a 45, 45, 90 triangle. And we can use that single formula, hypotenuse equals the leg root 2. We only have to say leg, we don't have to say short leg, because both of the legs are the same measure. So the hypotenuse is 4. The leg is x. You can put that in there if you wish. So we're going to divide by root 2 to cross those off and divide by root 2. When you divide a number by a radical, you need to rationalize that denominator. So you do that by multiplying the top and the bottom by the square root of 2. So 4 root 2 over root 2 times root 2, which is root 4, square root of 4, which is 2. Then you can reduce this. Again, a 30, 60, 90 triangle. We know that the long leg equals the short leg times root 3. You got to remember which formula has root 2 and which formula has root 3. These would be good formulas to have on your note card. So the long leg is 9 square root 7. The short leg is x times root 3. So we have to get rid of this root 3. And we would have to rationalize it. So we get 9 square root of 21 because the square roots multiply each other, but we don't multiply the numbers that aren't square roots. And root 3 times root 3 is the square root of 9, which is 3. And then the like numbers can be reduced. That is the hypotenuse. That's the y value. Oh, I'm sorry. That is the x value. That's the short leg. So now to find the hypotenuse equals the short leg, which is 3 square root of 21 times 2. So what you multiply to figure out the hypotenuse is just the like numbers. So you don't multiply a square root with a regular number. It's called a whole number in this case. So 6 square root 21. So next we're looking at these right triangles. And with this right triangle, notice that it is not a 30, 60, 90 triangle. So we cannot use those rules. X is not going to be twice the shorter leg. So here we have to use what's called trigonometry, and we often use SOHCAHTOA to help us remember what our ratios are. So from the 19, the 9 is the opposite side, the x is the hypotenuse. So we need to use opposite and hypotenuse, which is sine. So sine of the angle equals the opposite side over the hypotenuse. We place this over 1 and cross multiply. So x times the sine of 19 equals 9. From this point, remember, we want to get the x by itself. So we need to divide by the square root of 19. Divide by the, I think I said square root. Divide by the sine of 19 and divide by the sine of 19. So with our calculator, you want to be sure you're in degree mode. There's a little D highlighted on my calculator. If you're using a graphing calculator, you need to go to mode and be sure the degree is highlighted. One good way to test if you're in the right mode, do sine of 30 and you should get 0.5. Get a half. So 9 divided by sine of 19, that is 27.64. That is not a degree value, that's a length, so that's in units. This triangle, again, it's not 30, 60, 90, so we can't use our special right triangle rules. From the 62, x is the opposite side. The 25 is the adjacent side. So SOHCAHTOA, tangent is opposite over adjacent. Tangent of 62 equals the opposite side over the adjacent side. Place that over 1, cross multiply. 25 times the tangent of 62 equals x. So using our calculator, 25 times the tangent of 62 gives you 47.02. Here we have 47 degrees, which is pretty close to 45, but not quite. You can't use the rules for 45, 45, 90 if it's not that. So, from the 47, this is our adjacent side. This is the side next to it. Opposite is way over here. We are not interested in that number. And the hypotenuse, of course, is always across from the 90. So the cosine of 47 is going to be the square root of 13 over x, adjacent over hypotenuse. Place that over 1, cross multiply, we get x times the cosine of 47 equals the square root of 13. Then we divide by the cosine of 47, so x is going to be the square root of 13 divided by the cosine of 47, 5.29. Next we have some word problems. A boy flying a kite lets out 300 feet of string, which makes an angle of 38 with the ground. It's making an angle of 38 with the ground. So out here is your kite. It's got a little string, and the string goes down to the person. It's got the little ribbon. Then it has the string goes down to the person at a 38-degree angle. Assuming that the string is straight, how high above the ground? That's what we're wanting to find. And height is always measured perpendicularly. So what is the height if the string is 300 feet long? So the toughest part here is knowing where the numbers go. Once you get your picture drawn, opposite of the 38 would be the height, and hypotenuse. So using our SOHCAHTOA, like we talked about before, sine of 38 equals the opposite over the hypotenuse. The opposite is your height. So we place it over 1 and cross multiply. Notice here that the 300 would multiply the sine of 38, and the 1 multiplies the h. So all we have to do is take 300 and times that to the sine of 38. So it's 184 feet, 0.70, those are feet, above the ground. Okay, a ladder is leaning against a wall. So if you have a wall, you have a ladder leaning up against that wall. It makes an angle of 74 with the ground. If the foot of the ladder is 6.5 feet from the wall, so 6.5 feet from the edge of the wall, how high is the ladder? So the ladder, your height, again, is always measured perpendicularly to the ground. So in this case, from the 74, opposite is your height, and adjacent is your distance. So we're going to use tangent of 74 equals opposite over adjacent. Place that over 1 and cross multiply. And notice for these two past examples, there's no need to divide anything. We multiply the numbers together. In some cases, we have to divide like we did over here. In some cases, we just multiply. So just put together your proportions so you can see what method to use. So 6.5 times the tangent of 74 gives us 2267. And those are also in feet. On the next page, we have a airplane climbs at an angle of 11 degrees with the ground. So 11 degrees with the ground. Find the ground distance it has traveled when it obtains a height of 400 feet. So if the height is 400, how far does it take for that to occur? So that's our x value. So again, we're thinking about which trig function to use. So we use SOHCAHTOA to help us determine that. From the 11 degrees, the opposite side is your 400, and your adjacent side is the other leg. It's the leg next to it. And of course, the hypotenuse is across from the 90. We're only working with the opposite and adjacent, the O and the A. None of the others have an O and an A. OH, AH, OA. So tangent of 11 is going to equal the opposite over the adjacent. Here, because the x is on bottom, there's going to be some division needed. We're going to cross multiply. We're going to get x times the tangent of 11 equals 400. Divide by the tangent of 11. (400) divided by the tangent of 11. Again, if you're having troubles getting any of these numbers, most likely you're in the wrong mode. So it looks like these are feet again. Got to keep the units the same. A 25-foot ladder leans against a building. A big building. We have a 25-foot ladder. So 25 is the length of the ladder. The ladder base is 13 feet from the ground. I'm sorry, it's 13 feet from the building. 13.5. Find the angle of elevation. Ooh, exciting. So what is the angle that's formed? So we notice that that's the adjacent and the hypotenuse. So we're going to use cosine of some angle that equals the adjacent over the hypotenuse. So to figure out theta, we're going to do cosine inverse of 13.5 over 25. Set up your normal trig function first, and then to bring it over to the other side to get your angle by itself, you want to use cosine inverse. To get cosine inverse to come up on your calculator, you have to hit the second first. Second cosine will show you the inverse. You have to use parentheses here. So 57.32 degrees. Okay, we're going to use the calculator to approximate the value of A, angle A, to the nearest degree. So we're doing the same thing. We're looking for this theta. So from that angle, this is the opposite, this is the hypotenuse. So thinking about SOHCAHTOA, we're going to use sine of A to equal the opposite over the hypotenuse. We don't know what the angle is, but I can figure out the measure of angle A by moving my sine across using parentheses of 16 divided by 21. So second sine, parentheses, 16 divided by 21. 49 degrees, 0.63. In this case, we're looking for the angle. Opposite is across. Adjacent is next to. So we know we're going to use tangent of angle A, 17 over 12. Well, to move the tangent away so the measure of A is all by itself, we're going to use tangent inverse. You must use parentheses. So second tangent, 17 divided by 12, gives us an angle of 7.22 degrees. And I'm just checking over my work to see. I'm kind of surprised that that is such a small angle. So from angle A, opposite over adjacent, they're somewhat close to each other, so I'd expect the angles to be somewhat close to 45. So my tangent of A equals opposite over adjacent, so I do tangent inverse. Oh, but look, I didn't use parentheses. That's not going to work. Tangent inverse, you got to use parentheses, of 17 divided by 12. It's much closer to 45. 54.78 degrees. That looks better. Sine of A. So, well, it does look like we're still trying to find the angle of A. So we're going to say the measure of angle A equals sine inverse of 0.36. You can use parentheses here, but it's not an absolute requirement because it's not a fraction. So the measurement of A is going to be 21.1 degrees. And the measurement of A is going to be tangent inverse of 0.8. So the measurement of angle A is going to be 38.66. So those are called inverse functions, inverse trig functions. Okay, we're going to use the law of sines and law of cosines. We're going to find BC, which remember A is the side that's across from angle A, B is the side that's across from angle B, and C is the side across from angle C. The formula, we use a small letter to represent the side, a big letter to represent the angle. So we can use sine, law of sines, if we have two bits of information. But if you look here, we only have A's angle but not side, B's angle but not side, and C's side. But if we have the two angles, we know that this should add up to 180. So the measurement of angle C plus 118 plus 22 has to equal 180. So take your 118 and add the 22 to it. So we know that the measurement of angle C is going to be 40 degrees. So now, if this is 40, and if I need to find this side A, which is side with using the vertices BC, we need to use A, of course, because we're looking for side A, and we have the two bits of information for C. So those are the two fractions. With law of sines, you need to pick two fractions that you're going to use. A is our unknown, sine of 118, C is 24, sine of 40. So I'm going to cross multiply that one direction, so that my A is going to equal 24 divided by the sine of 118 divided by the sine of 40. 24 times the sine of 118, we get a number, divided by the sine of 40. So we get 32.97. Those are in degrees. Oh, sorry. That's a length. It's not an angle. It's a length. So it would be units or feet, but they don't tell us what units to use. So you could use the word units, or you could leave that blank. Okay, given this information, use the law of sines. So I like to draw my picture. We'll label it A, B, and C. So side A is across from angle A, side B is across from angle B, and side C is across from angle C. So A is supposed to be 11, B should be 33, C is 25, and the angle of B is 129. I didn't draw that proportionally, of course, but that tells me my relationship. So I know that I have to use B and sine of B because I have both bits of information, and I'm looking for angle C. So of course I need to use the C fraction. So law of sines cannot find an obtuse angle. It will never give you an obtuse answer. But because we already have an obtuse angle, we don't have to worry about angle C being obtuse. So we're fine to work with this. So 33 sine of 129 equals 25 over the sine of C. Here we got to cross multiply both directions. So 33 times the sine of C is going to equal 25 times the sine of 129. We'll divide by 33, and we're going to find out that the sine of C is going to equal 25 times the sine of 129 divided by 33, which is 0.5887. Then we have to do sine inverse of that value. I would either use all four numbers, but even better than that is to use the answer button. So sine inverse of our answer gives us the measurement of angle C to be 36.07 degrees. Don't use rounded numbers. Use the answer button and you'll do the best.